Okay, as I said, right, we're going to start a new project for this first demo to get our feet wet with this new WebAPI approach, right? And I'm going to I can type WebAPI up here to find ASP.NET Core WebAPI. I'll just click next. I don't want to call it that. I'll maybe call it first demo _ web API. Sure, that's fine. Okay, I'll just click next. Now, let me talk about this for a second. You probably on your system and in the college, they already have .NET 9 on here, right? But we're going to stick with .NET 8. It has long-term support. We're going to stick with it this term. So even if you're doing this at home or on your laptop, you probably already have .NET 9 available. Do me a favor, stick with .NET 8 for now, okay? Believe it or not, we're going to start without the plumbing for the identity system. We're going to leave the authentication type set to none, at least for now, right? We will leave it configured for HTTPS. We've seen already how we can change that when we go to run it, but eventually we will be running it up on Azure using HTTPS, so we might as well leave that there. These other options, I'd say leave as well. This open API support. We'll talk more about that, and I'll show you some of the neat things that it gives us when we get the demo up and going. But basically, it's, well, you might have seen it before, and it's in that first tutorial, and the buzzword used on the screen is Swagger, right? It's because there is no interface to a web API. It's just the data. What Swagger does is it gives us a way to kind of work interactively with the web API. It kind of puts this standard face to what the API actually provides, right? So we'll see how that works in our favor having that, right? And we're going to use controllers. There's two different styles you can use, just like you can now with MVC, but we're going to stick with controllers because that's what we know and love. Okay. Yes, of course, you love controllers. All right. So here we are. So I have my web API up and ready to go, right? And you see that there's a controllers folder. Now I can run this right now because the starter project is set up already to give us some weather forecasting information, right? Maybe I will. I'm going to change it just so I'm consistent with how you do it in the lab to HTTP because it really doesn't matter at this point for us, right? And I'll run the actual project before I even go in and do anything, just so we can see what this open API, this Swagger looks like. Okay, so this is this Swagger friendly face sitting on top of our web API, right? So here's an example here. Oh, it looked at here's a controller available. So it put it up here and look at it found a method, one method get, and I can expand this. Okay, there's no parameters, right? It gives you an idea even without running it of what kind of a schema. This is a JSON schema here of what the information is that we're going to get. I can click try it out and then I can click execute. So this is actual data being provided by the web API. Right? Now, it's set up, it shows us a success was the response, a 200 status code was returned, right? And so on and so forth. So that's just, again, the example schema. This is the actual data that was returned to us. Okay. Now, if I were to stop running right now, we're going to get into building our own demo, right? Instead of just using this weather forecast controller. Okay. Now, like I said, it's very much like MVC, but you see we have our controllers folder, but we don't see views and data and that kind of thing because this doesn't assume, right? Why would it assume that we are actually going to work with a database or anything? But that's our plan. We want to work with the database, and we have a choice of many different databases to work with. But once more, we're going to stick with the same one we did last term. We're going to use SQLite for now. So I do need to install some packages. We could skip this way we started our MVC projects because we always checked off that option to have the security identity system in place. We didn't do that this time, so I have to add everything from scratch. No big deal. We've done this before. Come down to our NuGet package manager and our package manager console, right? And in here, I'm going to, now because I know the version numbers, I can just type it in, right? So I can just get out of my copy paste file the install package command, okay? Because I want Microsoft Any Framework Core, SQLite, version 8.0.11, right? Now, what if you didn't know the version number, okay? Well, let me just show you, remind you, because we've seen it before, but I'll remind you, if you come down here to Manage NuGet Packages for Solution, right? Then I can go to Browse, and say I know the name of the package I want is Microsoft Entity Framework Core Tools. Okay, we need tools, of course, in order to do migrations, right? So if I put that in, okay, then it comes up, oh, here, but look, it's suggesting version 9, right? So I check off that I want to install it in my project, but now I can go back and I can see the history. So sure enough, 8.0.11. That was the last version compatible with .NET 8, right? So I might as well go with the most up-to-date one going back to .NET 8, right? So that's another way to get it. So I've given you in my copy-paste file the version numbers to use, but that's how you can get them if you're ever unsure yourself of what version to install. And I'll just click install. So this is basically doing the exact same thing that I managed just with the command line a moment ago for the actual SQLite itself. Okay, so I can see I've got, okay, oh, of course it's in the filter window there. So I see I've got my SQLite and my tools, both version 8.0.11. By the way, Swashbuckle, well, that's that open, that Swagger interface is this Swashbuckle. So that was installed already because of the option of how we started the project. All right, good. So now I have the plumbing in place to work with my database. What do we need now? Well, hey, the M in MVC, models, right? So I don't have a directory yet or a folder, but I like to keep things organized. So I'm going to follow the same good practices we did last term. I'll right click. We will begin by adding a folder for models. And while I'm at it, I know I'm going to want to keep all my data connectivity stuff organized. So I'll add another new folder called data. Again, very consistent with what we've done in the past. So let me come to models first of all. I have two classes I'm going to add here. You're going to be shocked at the names. Patient and doctor. I'm sorry, I didn't quite hear you. Or maybe that wasn't meant for me. Okay. All right. Good old doctor patient. Yeah, as we know, right? Okay. Now I'm just going to copy paste out of my file here. I mean, we've done this enough times. I don't have to really preach about this very much, do I? Now notice I am using data annotations. The red underlining will go away because it added automatically my using for the data annotations namespace from component model, et cetera, right? So I have a summary property here for the name of the patient, and it's pretty similar to what we did last term. There might be a couple little things that are different. Look, I've already added a row version, because sure, why not? We should be able to support concurrency here as well, et cetera, right? Eventually. Okay. One little difference, it might jump out to you right away, I'll maybe talk about. Here in patient, where we have the foreign key for the doctor, for the patient, the primary care physician, right? Notice that the attributes we have on here, I have my required attribute, but I've also thrown in something we didn't use with MVC, a range between 1 and, because it's an integer, I went with max value, right? The reason I'm doing that is just depending on the type of client we eventually have that works with our actual web API, it is useful sometimes to be able to give them this specific message because they might pass a value outside of that range that they think is a valid value, but we need to inform them that it's not, right? So that's why we added this extra annotation here. Other than that, it's set up the same way we have in the past, right? The doctor object itself, we make nullable. Because let's face it, sometimes we just want to get the patient record and we don't really need the name of the doctor, right? So we don't need to do a dot include on the doctor, right? Now, when it comes to the doctor object, let me get my code in place. Okay, similar idea, right? Down here we have our I collection of patients. And of course, things are either going to be nullable. So our row version, of course, is nullable. If it's not a nullable string, then we'll assign a value to it. Of course, the middle name we've always had as a nullable one, so that's not a big deal, et cetera, right? So slightly different. Compare them if you want to. Slightly different from the models we used in the past. I've done a couple quick little changes to make it a better example for WebAPI. But we have our models, mostly the same. Now let's come to the data folder. What do we know we need? Well, we need a DB context, right? So that is just a class as far as we're concerned right now. I'm going to, once more, call it my medical office context. Now I will have it inherit from DB context. And of course, we need to add our using for Entity Framework Core. Okay. Now again, because this is repeated stuff that we've done before, I'll just get my code in place and we'll quickly talk about it before we move on, right? So, just my constructor here, we're going to expect to get the context object available through our dependency injection system. We'll have to do some work in program CS to make sure that's ready to go. We have our two DB sets for doctors and patients, right? And then in our on-model creating with the Fluent API, we're going to take care of the obvious things like you shouldn't be able to delete a doctor that has patients assigned, right? We're adding a unique constraint to the OHIP number. That's a little different. The OHIP is required here. We're just keeping it simple, right? OHIP is a required field and then it has to be unique, right? And then to deal with multiple births of our patients, we've added a unique index here to the combination of the date of birth, first and last name, right? Quite often, people will name their children, okay, after themselves or grandparents, things like that. So, combination of first and last name is definitely not enough. But if you have two people with both the first name and the same last name, born on the same day, that's pretty unusual. So we're pretty safe to create this constraint just to avoid an obvious chance of entering the same patient twice, right? And besides, it's good to have constraints that we can test and make sure that our error handling is working properly, right? Yeah. Okay. All right. So that's good. That's all we need for now in our DB context itself. All right. Now, as you recall from last term, we usually need, or it's useful to have some kind of initializer in place, right? To get the database ready, seed required data, et cetera, right? So we're going to add another class here. I'm going to call it, once more, my medical office initializer. You see, so far this is so much more the same as MVC than different, but the differences will become clear very, very soon. Okay, now there's a fair chunk of code in this, a little bit of a copy paste going on here. I apologize for that, but this, I think, no chance of me trying to do it a step at a time otherwise, so I better try and get it all at once. But don't worry, it's nothing you haven't seen before for the most part, right? Okay, so we're going to prepare the database, seed data as required. Once more, we're using the same approach when we call the initialize method of our medical office initializer. We can pass the service provider through dependency injection and options. Do we want to delete the database first? Do we want to use migrations? And do we want to seed our sample data, right? Then using our actual context object, we'll go through and we'll do all that. The usual stuff here, we're preparing the database. This is the same code essentially that we used last term. But notice I've already added in here triggers, right? Why? Well, we have triggers for our concurrency control here on patient, right? So we update the timestamp on patient when we do an update or when we do an insert on patient, right? So we'll execute all that. And we have also a timestamp in doctor. So we have to create triggers on the doctor table as well. So for after update and after insert to set a new value to the row version each time, right? That's the same kind of code we did last term, but we're starting off using it right away right now. So then the database, if it's already created, then we'll just call migrate, right? Okay. And then, of course, here's the region where we seeded required data for production and during development. Hey, look at that. There is none. But I have this in my, because I might add some later on. I might come across something I want to add that should be there even in production. So I have the spot ready for it. And then seeding sample data. Again, I have a random number generator I'm going to use because it's often much more meaningful to have lots of data, especially when you start eventually applying filters and things like that, right? We want to have lots of data to work with. So I also do, as you've seen in the past, I find it helpful to have a handful, even 2 or 3 kind of standard records that we add or objects that we add to our collections, just so I can anticipate that I'm going to have a Gregory House, a Doogie Hauser, et cetera, right? So I'm going to hard code values for 3 doctors, okay? And then for patients, by the way, this is just to disable the warning about possible null exceptions. That's one thing that you could do. You could take this out. It just means you get the green underline over here, right? That's not a big deal one way or the other, okay? Okay, and then if there's no patients, I'm just going to manually add a few patients here, okay, with various values for birth dates and middle names, et cetera, and assigning them to one of our predefined doctors. Of course, that is one thing I should maybe mention before going on. Why did I do doctors first? Because patients have to have a doctor assigned, right? So I have to have the doctor there so I can go and then relate it to the patient. Okay, now we're going to leave those in place, but add a bunch more with random values. So, I set up this way as well. If you really don't want a huge amount of data to clutter up the screen, you could just comment this section out here, this try-catch, and then not generate all these meaningless, because they truly are meaningless, just random first names and last names, doctors and patients, and leave that out for now if you want. But I'm going to leave it there at this point in time. And then this code, we did the same thing. Because we're creating a bunch of random doctors and a bunch of random patients. So we might have some doctors without patients. So just to clean that up, we're deleting doctors where we do not have a patient assigned. And that's it. Okay, so really nothing new in here. The same kind of coding we did last term as well. Now, of course, we aren't quite done yet because we know we've got to have a few more things in place. One of the obvious things missing, we don't have a connection string. In fact, look at that. We don't even have a section in our app settings JSON file for connection strings. Well, good thing we can fix that easily because we've done it before. We know exactly what's required. So there we go. I'll create a connection string section here, my medical office context, and I'm just using the one database. So it's just my medical office DB is the file name. Nice simple connection string because I'm using SQLite. But we're still not done. Program CS, some work to do here. For one thing, there was a whole bunch more code in our MVC version, right? Well, that's part of the reason was because we, once more, checked off that option to have all of the information in place for the identity system, right? No, I think someone sent me a chat message. I'm just checking. Yes, the class is being recorded. Yeah, sorry. All right, good. Okay, so I'm going to actually have to add the DB context here so that it can be available through dependency injection. So a bit of a note here. Notice this comment here is to help us out, add services to the container. So it's after you initialize the builder, right? That's when you can start adding code like this, but you have to do it before here, right? Because that's when you actually build, right? So anything we're going to add to the dependency injection system has to come between here and here, right? So we're fine here. So I'm going to add my DB context for the medical office context, okay? And I didn't create a separate connection string as a variable, so I'm just passing the connection string here, getting it from my app settings JSON file and providing it when I call use SQLite. Now the last thing I'm going to add in here is code pretty much the same as we did last term. Usually right before the end, before I go .run, to actually call my initializer. So I, use my scope of my services, okay, get the service provider, and then I can pass that in now as I call initialize. So I'll set for now delete database true. Might as well just delete it. Oh, look at that. Use migrations false. Why do I have that in my copy paste file? Well, believe me, we certainly can use migrations. Something I really almost feel bad that I didn't do more examples of last term. Here's a confession. Sometimes when students would hand in a project and it was broken because the migrations were all messed up, it was sometimes easier for me, rather than delete your migrations and recreate them again, all I would do is I would say here, false to use migrations. We talked about it, so you should remember what that does. Basically what that does, if I come back here to the initializer, go up to the top again, right? What does it do if we pass in false there? Okay, so come down here, right? Oh, sorry. I'm getting lost in my own code. All right. If you use migrations, then we call migrate. If we don't use migrations, we just call ensure created. Remember, we talked about that. It takes the current state of your model, okay, for the context itself, and it just basically creates, without ever saving it as a file anywhere, just creates the migration to instantiate the database according to the current design of your model, right? It doesn't give you any history, so you can't, make incremental changes, go forward and back through migrations and try things out. But it does basically just say, whack, we're starting a new database, and we're just going to create it according to the current status, the current state of the model itself, right? So it's an easy way. I can skip over even making the migrations folder, right? I don't even need to worry about migrations doing this approach. Eventually, though, we are going to want to go back to using migrations. So if I have time, we'll go back and actually add them then. In my copy-paste file, I do show how you can actually do that, add your commands, and then add the migration, et cetera, and away you go. It's not a big deal. We've done so much work with migrations, but I thought it'd be fun to show you that we actually, even though I've never made a migration, I can still carry on using ensure created. Before I leave this, though, let me warn you, big warning. The downside of ensure created, if the database already exists, it doesn't matter if there have been changes to the model, added new properties to a model class or anything like that, forget it, okay? Changes are ignored. And if the database exists already, it will just carry on and it won't apply any migration. It won't do anything, right? So you'll be out of sync. Your model will not be synchronized with the schema of your actual database. So that's why migrations in most situations are the better approach. Okay. All right. So I should actually be able to run right now. Pardon me. Of course, we don't see anything. I haven't added any new controllers. But it should have created the database, right? So let me just test here. Let me go in here, get my SQLite up, click my little add. There's my medical office. Look at the tables, and there's my doctor and patients, right? I can right-click, and there we go. So there's all my doctors, et cetera, all my patients. So yeah, it did. It created the database, so I know that it's actually working that way. Now, of course, until I actually make a controller, there's no hope of me doing anything with any of the data that I've just created, right? So let me just close all tabs here, clean up the screen. So we've got our weather forecast controller. Let me come here. I'm going to right-click. We're going to add a controller. Danger. Danger, Will Robinson. Careful at this stage. Look at this. API. Remember, we're doing a web API, right? So we need to actually have a web API controller. Sorry, I see a hand up there. Let me just pause for a second. TJ, you have a question or something? Oh, if I had delete database. Well, because I never had, the database didn't exist. Sorry, to back up the question, you can probably all see it in the chat window. Would we run into issues if we had delete database false? Because it's the first time running it, there was no database. So I wouldn't have had a problem at this stage. But if you made any design changes to the models now, if you didn't say it true to delete the database, then yeah, you could easily get into trouble, because if you don't delete the database, it doesn't create it according to the current status of the model. All right? Okay. Yeah. Yeah. So you got to be really careful if you're not using, because you've got to make sure if you make any changes that you delete the database if you're not going to use migrations. Okay. Getting back to my scaffolding, my controller here, make sure you select API first. And there's two choices, but we are using controllers. We aren't using endpoints. We're using controllers with Entity Framework. So I'll click Add. Okay. So, of course, I have to choose the model class. I don't know which one. I guess I'll start with patient. We'll eventually do both if we don't run out of time. Ooh, gosh, time is flying. Medical office context, patient, okay? And, I have to be honest, it was important when we were doing our MVC to make this a singular form, the name of the controller. So I have no problem if you want to continue the practice as we did it last term. I'm going to get rid of the S. But you know what? If you leave the S there, if you leave it in a plural form with WebAPI, it's really not going to matter. In fact, reading the code almost sometimes makes more sense with the pluralization. But to be consistent with how we did it last term, I'm free to take out the S. I mean, I could call it anything I want as long as I know what I called it, right? So I'll click Add. So this should take a few moments, but shouldn't take too long. All right. Now, right away, you'll notice some differences. Look at that. It's inheriting from controller base. Slightly different class than our MVC controller, right? And you notice we use some annotations here as well. It is actually marked, okay, as a API controller. And here is where we provide routing information. Now, we'll come back, we'll talk more about this later on. But basically, to get to the information itself, in the URI, we go /API/ the name of the controller, right? And that's a standard approach. Even the weather forecast controller, if I come back here, okay, now you see it's, because it was just the boilerplate stuff, it's a little bit different. It just says the controller is the route, right? But we're going to do everything under /API to keep it organized that way. All right. So here we have the constructor for the controller. We get our context passed in. Good. We know we're going to need our context to talk to the database. So here is our get, right? So our get, very familiar link query, context, patients, to list async. Where we go, asynchronous task, returning a collection, IEnumerate collection of patient objects, simply called get patients, right? Excellent. Okay, here's get a single patient, okay, where we pass in the ID. So it looks more similar, right, than it does look different from our MVC. But notice the annotations. So that's just a straight HTTP get with an ID, right? And we're going to leave the actual, let me just go Control MO, right? There's actions here for put, post, and delete. Now, for those that I've already seen, we talked about how the history got in place, why these particular verbs were used for the different actions. We are not going to get that far today anyway, so we're going to focus mostly on the gets, getting data and returning it. That's as far as we're going to have time for today anyway, and I'll see section 3 and 4 in class, and we'll get into that other material. All right. Now, one thing we can do here is I'm going to say, you know what, it's great to get the patients. You know, I'm going to run out of room to demo everything I want. So might as well be as thorough as I can here, and I'll just do some more recordings and get them posted, folks. Okay, look at that. Swagger's already detected. Wow, you have a new controller, a patient controller, right? And I can try it out. I can come here, I can execute the get method, which is basically get all patients. And there they all are, right? Now notice what we're getting exactly what the properties are of the patient class. The ID, the summaries there, first, middle, last name. Doctor ID, the doctor, of course, is null. Why is the doctor null? Well, anyone? Feel free to put it in the chat or raise your hand if you know the answer. We didn't do a dot include, did we? Right? We won't actually get the doctor object unless we ask for it. So we go dot include. What do we want to include? Well, we want to include, I don't know, it's patients here. P, goes to P dot doctor. Okay, so I'm just going to make that one change here. I didn't actually need to stop. I could have just done a hot reload, but anyway. So now when I come in and get patients, try it out, execute, and wah, 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 wah. Aha, a possible object cycle detected. Maximum allowed depth of 32. So yeah, we'll talk more about this for those I haven't seen yet in class on Friday. But basically what's happened, right, is we've come in here to the doctor, or the patient, I should say, right? We materialized the patient. We came down here, but we included the doctor. Oh, good. All right, so let's go and get the information for the doctor. So we came down and we started to build the doctor with all the data from the database. And we came down here. Oh, here are all the patients for the doctor. Oh, well, let's go get them as well. So we got all the patients, right? And then, for each patient, we came down and we got the doctor. Oh, well, we've got the doctor, but the doctor contains this list of patients. And we went round and around and around, and we chased our tail until we finally, after 32 cycles around, trying to serialize all that data, the system just gave up, right? So we're going to talk about and look at a number of different approaches to solve this, right? You know, as I have here in my copy-paste file, you know, I'm showing my age here, but that's okay. You know I'm pretty old as it is, right? Oh, sorry, meant to go down here. Okay. Error, danger, Will Robinson, danger, okay? Object cycle was detected. We have a circular reference, right? Because that is how, I taught you that that's how we actually want to set up our relationships in our model classes, right? So there's a number of fixes. I'm running out of time, so I'm not going to look at these global ones that we'll never use in the end anyway. I will play around with this. This is another fix. We can just add an annotation called JSON ignore, right? So if I put that, it doesn't hurt. Like if I was going to combine, by the way, you can do that. I can combine MVC controllers and WebAPI controllers in the same project, right? So if you ever needed or wanted to, okay, adding JSON ignore on the I collection of patients, notice I'd need a new namespace, system text JSON serialization, right? It would not hurt whatsoever if I was doing this as an MVC application. Okay, there's no problem doing this, right? It won't change how the MVC app works. It just means that when we serialize the information as JSON, it will not chase its tail. It will not go around and around, back and forth between the doctor and the patients and the doctor and back and forth, right? So just with that one little change, let me run it once more and show you the difference there. So I can try out my get for patient and look at that. So you can see here we have Fred Flintstone. We come down to the doctor, and here's all the properties for the doctor. No problem. We come down to each one and we're getting the doctor information. Away we go. No issues anymore. We've solved the problem. And you might say, hey, that worked pretty good. What else might we use it for? Well, I pointed out earlier, look at this summary data. The full name, right? First name, middle name, last name, all that kind of stuff all put together. Well, we found that was very, very useful last term in our MVC applications for sure, right? And for sure it's useful to have that in our objects, in our model classes, on the client, on the server. But you know what? It's totally, completely useless passing that information back and forth between the server and the client, right? Because everything is there, right, to reconstruct that summary, right? So I'm just bulking up, okay, the amount of data being sent in JSON format by having that summary property there. So I can, for example, here, I can put the JSON ignore annotation, come up here to my formal name, put it on there, to my summary, put it on there, come over to patient, okay, put it on the summary property here. Now I have to add, I already had the using in place for system text JSON serialization in the doctor class, but I have to add it here as well, right? And we'll just see that final bit of change as we run it again. Oh, sorry, I guess I should be able to actually bring it up. Yeah, okay. So once more, coming in, we'll try out our basic get. And you see, we've just cut out all that duplication, right? So the doctor is much smaller, right? Because we're really just showing the first, middle, last name. We have the row version there, right? We'll deal with that later on. Really, any concurrency control would only be on the patient. We aren't worried about when we're updating a patient, whether there have been any changes to the doctor's first name or anything. So we'll deal with that later on. But you see, we've cut down the bulk, the duplication of data as well. So that's another useful aspect of the JSON ignore annotation. All right. Okay, well, you know what? This has been a pretty long recording and class is almost over. So I think I'll stop the demo at this stage. I will complete my demo and record step 2, and I'll get all of this posted up onto our video channel so you can watch these video recordings when you have time. So let me just stop the recording for now.